Right now, somewhere in your tenant, an AI agent has access to your most sensitive data, and nobody can tell you who owns it. That isn't a hypothetical scenario. It's the reality for most organizations today. But here's the problem. You're treating AI agents like simple apps or service accounts. That's a structural error. It's going to cost you control of your data, your identity fabric, and your compliance posture. The move from Copilot to Agent 365 isn't just a feature update. It's a governance architecture change. By the end of this, you'll understand why Agent ID is the only real path to scaling AI without losing accountability. Because the window to get this right is closing fast. The problem nobody's talking about. Let's start with what's actually happening in your tenant right now. Because it's probably not what you think. Shadow AI agents are multiplying. Someone in finance spun up a Copilot Studio bot last quarter. Someone in IT built an automation script that calls into Graph. And someone in HR connected a chatbot to SharePoint. None of it went through a formal review. None of it shows up in a clean inventory. And none of it was built with the assumption that it would need to be governed, audited, or retired someday. But here's why this happened. Service principles, the identity objects most of these agents rely on, were never designed for autonomous tool-using AI systems. They were built for a different job entirely. The container doesn't match what you're putting inside it. That mismatch shows up first as credential sprawl. Secrets get scattered across scripts, pipelines, and vaults. Sometimes they're hard-coded, and sometimes they're rotated on nobody's schedule. Every one of those secrets is a door. And when you've got hundreds of agents, each holding their own credential, you've got hundreds of doors. Most of them are unlocked. Most of them are forgotten. Then there's the orphan problem. An agent gets built for a project. The project ships, and the person who built it moves teams or leaves the company. The agent keeps running. Nobody knows who owns it anymore. Nobody knows what it's touching. And nobody knows why it still exists. It's not malicious. It's just unaccounted for. And unaccounted for is exactly the condition auditors hate most, which brings us to compliance risk. This is where it gets serious. When an auditor asks, who authorized an agent to read customer records? You need an answer that traces back to a human decision maker. Right now, for most organizations, that trace goes cold. The service principal shows a client ID. But it doesn't show a person. It doesn't show a business justification. And it doesn't show a review date. You're left explaining a gap, not a control. And here's the part that should really get your attention. This is small right now. Microsoft's own internal numbers point to adding thousands of agents a week, and they expect to have more agents than employees before long. The direction is the same everywhere. You're heading toward a population of non-human identities that outnumbers your human workforce. And you're using a governance model that was never built to handle scale like that. Think about what your identity team currently does for a new employee. Background checks, role assignments, access reviews, manager sign-offs, offboarding checklists. Now ask yourself, does any of that exist for the agent your marketing team spun up last week? For most companies, the honest answer is no. There's no onboarding, there's no offboarding, there's no manager. There's just an app registration sitting quietly in the directory, doing whatever it was told to do, for as long as nobody notices it. That's the setup. Now let's diagnose exactly why the tool you're using to solve this problem is the wrong tool for the job. Why service principles fail for AI. To understand the fix, we need to diagnose why the old model breaks. And it breaks at the architecture level, not the configuration level. Service principles were built for static, long-lived applications. Think of a billing system that calls an API every night at 2 a.m., or a back-end service that syncs data between two systems. That workload is predictable. It does the same thing the same way on the same schedule for years. You register it once, grant it permissions once, and mostly leave it alone. AI agents don't behave that way. They're dynamic. They're often ephemeral, spun up for a task, run for minutes, and then they're gone. They make decisions based on context that changes from call to call. An agent might read a document, decide it needs another data source, call a different tool, and then hand off to another agent entirely. That's not a static workload wearing a slightly different hat. That's a completely different operating pattern, and the identity model underneath it needs to reflect that. But here's where the architecture actually breaks down. A service principal has a one-to-one relationship with an app registration. One app, one service principal per tenant. There's no concept of instancing built in, so if you want 20 instances of the same agent doing slightly different jobs across 20 departments, you don't get 20 identities with a shared lineage. You either build 20 separate app registrations manually, one at a time, or you cram all 20 use cases behind a single identity and lose any ability to tell them apart later. Now multiply that by credential management. Every service principal needs its own way to authenticate, whether that's a secret, a certificate, or a managed identity binding. Thousands of agents means thousands of credentials to create, rotate, and protect. Most identity teams already struggle to rotate secrets on a few hundred service principals. Ask them to do that across a population of agents that outnumbers their employees. And the answer isn't, we'll manage it. The answer is, we'll stop rotating them, which is exactly how credential compromise becomes a matter of when, not if. Logging makes this worse because it hides the very thing you need to see. When a service principal acts, the logs show that service principal's identity as the client. If you've got one identity standing behind 50 logical agent instances, every one of those 50 shows up looking identical in your sign-in logs. You can't tell which instance did what. You can't build an audit trail that says this specific agent running this specific task accessed this specific record. You just get a wall of identical entries and no way to pull them apart. So what do most teams do when they can't scope permissions per agent? They overprivilege the whole class. Instead of granting narrow, task-specific access to each instance, they grant broad permissions to the shared identity, because narrowing it down would mean building separate infrastructure for every use case. That's not a security team failing at their job. That's the identity model forcing them into a bad trade-off. And then there's retirement, or rather, the absence of it. Classic service principles don't come with lifecycle governance baked in. There's no expiration date tied to business need, no automatic review cycle, and no clean deprovisioning path. An agent finishes its purpose, and the service principle just sits there, credentials intact, permissions intact, waiting for someone to remember it exists. Nobody does. That's not a policy gap. That's what happens when the underlying object was never designed to expire in the first place. The event that changed everything. Microsoft saw this coming. Here's what they built to fix it. Mark the date, May 1st, 2026. That's when Agent 365 and Entra Agent ID reached general availability. And I want to be precise about what actually shifted, because it's easy to hear new product and tune out. This isn't a new product, it's a new identity type. Up to this point, every non-human actor in your directory has been forced into one of two boxes, user or application. Agent ID creates a third box. An AI agent is no longer a hidden component riding inside an app registration. It's a first-class identity, sitting alongside users and service principals in Entra ID, with its own object, its own lineage, and its own governance surface. Here's how they solved the instancing problem we just walked through. Instead of one app registration producing one identity, Microsoft introduced the blueprint. A blueprint is a template, created once, that can spawn hundreds or thousands of individual agent identities. Each instance gets its own object ID. Each instance shows up separately in your logs. 20 departments running the same agent type no longer means 20 manually built registrations or one blurry shared identity. It means one blueprint, 20 distinct trackable instances. Then there's the credential fix, and this is the part that should actually change how you sleep at night. Agents themselves don't hold secrets. The blueprint holds the credential, whether that's a managed identity, a certificate, or a federated trust. The agent authenticates through the blueprint, not with its own standalone secret sitting in a script somewhere. So instead of thousands of credentials scattered across your environment, you're managing a much smaller number of blueprint-level credentials, centrally, with real rotation discipline behind them. And here's the piece that directly answers the orphan problem. Every agent identity now requires a sponsor. Not a developer, not a team alias, but a named human who is accountable for why that agent exists, what it's allowed to touch, and whether it still needs to exist next quarter. No sponsor, no agent. That single requirement closes the gap that let agents linger for years without anyone able to explain their presence. I want to be clear about what this is not. This is not Microsoft bolting a dashboard onto the old service principal model and calling it agent governance. This is a rebuild of how identity works for non-human actors from the object type up. The instancing model, the credential model, and the accountability model all break from what came before at the same time because all three problems were connected. That's the shift. Now we need to open it up and actually look at how a blueprint works piece by piece, because the architecture itself is where the real discipline lives. Understanding agent ID blueprints. The architecture is elegant once you see the pieces laid out. But here's the problem. Most people think of an agent as a single object. In reality, it starts with the blueprint. Think of the blueprint as a reusable template. It defines three things: what the agent is, what it's allowed to do, and how it proves its identity. You build this once, and inside that definition, you set the roles, the Microsoft graph scopes, and the authentication method. Everything downstream inherits from this. That inheritance is where the scaling happens, because one blueprint doesn't just produce one agent, it produces a class of agents. You could spin up 10 instances for regional offices or 2,000 instances for customer accounts, and every single one traces back to that same template. The blueprint isn't just a naming convention or a folder structure, it's the actual source of permissions for everything spawned underneath it. But here's where it gets useful for real-world design. Permission inheritance isn't all or nothing. Agents pull their baseline roles from the blueprint, but individual instances can pick up extra permissions on top of that. A finance agent built from a shared document assistant blueprint might inherit read access to SharePoint by default, but then it gets a specific grant to touch a finance-only data source. You get consistency at the class level and precision at the instance level. You don't have to rebuild the whole permission set from scratch every time you need a new instance. Now let's look at the authentication model. This is the part that actually removes the credential sprawl problem instead of just relabeling it. The blueprint holds the credential. That could be a managed identity, a certificate, or a federated trust. The agents themselves never touch a secret directly. When an agent needs to act, the blueprint acquires a token on its behalf and performs a token exchange. The resulting token identifies that specific agent instance as the client, It sounds technical, but the payoff is simple. Your audit logs show the individual agent, not a generic blueprint identity, even though the blueprint did the actual authenticating. That distinction matters more than it sounds. It means you get centralized credential control and per instance accountability at the same time. You're not choosing between easy to manage and easy to audit. The architecture gives you both. The blueprint absorbs the operational burden. The agent identity absorbs the responsibility for the audit trail. One more piece worth understanding. Agents operate in two distinct modes. Attended agents act on behalf of a signed-in human. They use delegated permissions, much like how an app acts as you when you grant it consent. Unattended agents act under their own authority entirely. There is no human in the loop, and they run against app-assigned roles through standard RBAC. It's the same blueprint architecture underneath, but the risk profiles are very different. When you put all of this together, you can see what the design is actually doing. It's not adding complexity for its own sake. It's centralizing the parts that are dangerous to leave decentralized, like credentials, while decentralizing the parts that need precision. That's the trade the old service principal model could never make. It had no concept of a blueprint sitting above the identity. With that structure in place, we can zoom out and look at the full identity hierarchy. Blueprints are only one layer. The identity hierarchy. We need to understand the layers of identity that make this work. Because in reality, Agent ID isn't one object, it's a stack. Each layer exists to solve a governance problem the layer below it can't. Start at the top. The agent identity blueprint is the template we just walked through. It's owned by whoever built it, whether that's your internal platform team or an ISV. This is the master definition, and it isn't tied to any single tenant yet. Below that sits the blueprint service principal. This is where the blueprint actually lands inside your tenant. When your organization consents to use a blueprint, you get a tenant-specific manifestation of it. This is the object that holds credentials and does the authenticating. It's the operational anchor. It's the thing your identity team can point to and say, this is the trust relationship we approved. Then underneath that, you get the agent identities themselves. Each instance spawned from the blueprint is its own service principal, but it's tagged with a specific subtype, agent. That subtype matters. It's how Entra ID and conditional access know to treat this object differently from a regular application. There's an optional fourth layer, and this is where things change. The agent user exists for agents that need to act more like co-workers than backend processes. These are agents that need an exchange mailbox, a presence in Teams, or visibility in the org chart. A backend automation pulling nightly reports doesn't need to show up in a Teams conversation, but an agent that's meant to be mentioned in a document or looped into a channel needs a user-shaped presence to make that natural. This layer is tied back to its parent agent identity, so the lineage back to the blueprint stays intact. And here's the part that ties the whole stack together. Every one of these objects is a native Entra object. They aren't bolt-ons or shadow directories living outside your normal tools. They participate in conditional access the same way a user does. They show up in access reviews. They get evaluated by risk detection. You're not learning a parallel system. You're extending the one you already run. This hierarchy matters because it gives you multiple altitudes to govern from. You can set policy at the blueprint level to ensure a baseline is never missed. You can also scope policy at the individual instance level when one particular agent needs tighter restrictions than its siblings. And where an agent user exists, you can govern access at that human-facing layer too. You can control what it can see and do inside Teams or Exchange specifically. None of this was possible under the old model. A service principal was a flat, single-layer object with no concept of lineage above it or presence below it. Now, you get a structure that mirrors how your organization actually thinks about accountability. You have a template someone owns, an instance someone sponsors, and a face your employees can recognize and work with directly. That layered structure is what makes the next piece possible. Once you have identity organized this cleanly, governance stops being something you write down in a policy document. It starts being something the architecture itself enforces, and governance as physics. Governance isn't a policy document, it's architecture. The blueprints and the hierarchy we built. They aren't just for organizing identities. They are a physical structure. They enforce rules whether you remember to check them or not. It starts with sponsor accountability. Every agent needs a named human tied to its existence and its behavior. Not a distribution list, not the platform team. A specific person. That requirement isn't a suggestion sitting in a wiki. It's a field that must be populated before the agent identity can even exist. If you try to spin one up without a sponsor, the system blocks you. That's the difference between governance as a document and governance as physics. One relies on people reading and complying. The other simply won't let the object exist in a non-compliant state. The same logic applies to access reviews. Agents now sit inside the same review cycle your human accounts already go through. Periodically, someone has to confirm this agent still needs the access it holds. This isn't a new committee meeting you have to schedule and hope people show up to. It's the identity governance tooling you already run, extended to cover a population that used to sit entirely outside of it. Lifecycle policies work the same way. You can attach expiration to an agent identity based on business rules. Instead of an abandoned service principle quietly holding access for years, you get automatic deprovisioning tied to actual need. Renewal isn't assumed, it has to be justified on a schedule, or the access lapses on its own. Then there's least privilege. This is where the blueprint inheritance model pays off in a governance context. Permissions get scoped per agent instance, not blanket granted to an entire class of agents because scoping individually felt like too much work. The blueprint gives you a consistent baseline. Instance-level grants handle the exceptions. Nobody makes the old trade-off of over-privileging the whole group just to avoid managing scope one agent at a time. Conditional access extends into the same structure. You can block, challenge, or require additional controls based on an agent's risk signal or its location. This isn't a separate security layer bolted on top. It's evaluating the same identity object that the blueprint spawned, the same object that holds the sponsor field, the same object showing up in your access reviews. One identity, evaluated consistently across every governance surface you already operate, and audit trails close the loop. Every action an agent takes carries lineage back to its blueprint and its sponsor. When something goes wrong, you aren't staring at a generic client ID wondering which of 50 instances did the damage. You're looking at one specific agent, one specific sponsor, one specific chain of accountability, all the way back to the template it came from. This is why I call it physics rather than policy. Policy is something you write and hope people follow. Physics is a property of the structure itself. It's a rule the system can't violate because the architecture doesn't allow the violation to occur. Sponsor requirements, access reviews, lifecycle expiration, scoped permissions, conditional access, audit lineage. None of it depends on someone remembering to enforce it manually. It's already built into the identity fabric itself. That's not governance theater, that's enforcement, structurally guaranteed. And this leads directly to the next problem. What happens when these governed agents actually start touching your data? The data access problem. Agents touch data. This is where governance becomes critical. Everything we've covered, blueprints, sponsors, lifecycle policies, exists to answer one question. What happens the moment an agent reaches into your systems? And agents reach far. SharePoint, OneDrive, Teams, Exchange, plus whatever line of business systems you've wired them into. That's not a narrow surface. That's most of your organization's working data. It's accessible to an identity that, without the structure we've been building, has no clear boundary around what it should and shouldn't touch. The risk is simple. An agent with broad access and no clear scoping isn't just a compliance gap. It's a lateral movement vector. If you compromise one agent with wide permissions, you haven't just compromised one task. You've compromised every system that agent could reach. This is exactly why the scoped per instance permission model from the blueprint architecture matters so much. A tightly scoped agent limits the blast radius. A broadly privileged one hands an attacker a map. This is where Purview comes in as the enforcement layer. DLP policies that already govern how your employees share and move data now apply to agent activity too. An agent doesn't get a pass just because it's automated. If a policy blocks a human from emailing a sensitive spreadsheet externally, that same policy blocks an agent from doing it on someone's behalf. Classification and labeling work the same way. Agents respect sensitivity labels and information protection policies the same way a properly configured user session does. A document marked confidential doesn't become readable just because the thing requesting it is an AI agent instead of a person sitting at a desk. There's a principle here. No source, no answer. An agent should only provide information it can actually ground in an enterprise source it's authorized to see. Not something it inferred, not something it guessed at from a training pattern. It needs to be something it can point to and say, here is where this came from. That grounding requirement is what keeps an agent's output tied to something auditable instead of something invented. And because agent-generated content is discoverable, it falls under the same e-discovery and legal hold processes as anything a human produces. If an agent drafted a summary that ends up relevant to litigation, that content doesn't sit outside your compliance tooling just because no human typed it. It's part of the record, same as anything else. Put all of this together and you get something most organizations could not answer 6 months ago. What data is this agent accessing and why? Not a vague sense of, it probably touches SharePoint somewhere. A specific, traceable answer. It's backed by scoped permissions, DLP enforcement, label compliance, and a grounding requirement that ties every response back to a real source. That answer is the whole point. Data access without that answer is just exposure waiting to be discovered by someone other than you. Data access with that answer is a governed system doing exactly what you designed it to do. The security shift. Security changes when agents become first-class identities. It doesn't change a little. It changes completely. Because up to now, we've been applying human-shaped tools to a non-human problem. We were just hoping the fit was close enough. It wasn't. Start with risk detection. Entra ID protection now reads threat patterns specific to agents. It doesn't just borrow signals from user risk models anymore. That distinction matters. Agent behavior doesn't look like human behavior. We'll get into why that comparison breaks down in the next section. But for now, the important point is this. The system actually understands what normal looks like for an agent. It isn't just looking for a person pretending to be one. That understanding feeds your anomaly detection, unusual data access, activity crossing tenant boundaries, a tool getting called in a way that doesn't match the typical pattern. Any of these can trigger a block before the damage spreads. This isn't a report generated the next morning for someone to review over coffee. It's real-time evaluation. And it's tied to the same identity object carrying the sponsor field and the blueprint lineage we already covered. Conditional access gives you the mechanism to act on that risk. You can require MFA equivalent controls, demand device compliance, or restrict network conditions. But you're doing it for agent identities specifically. An agent operating from an unexpected location can be challenged or blocked using the exact same policy engine already protecting your human accounts. One engine, one set of rules, extended to cover a population it was never built to see before. Managing this requires someone with the right scope of control. That's why there's now a dedicated agent ID administrator role. This isn't the same as handing someone global administrator and hoping they use it carefully. It's a role built specifically for managing agent identities and blueprints. It's narrower in scope, it's purpose-built for the object type it governs. Early implementations of this role showed some scope overreach into non-agent service principles because agent identities are built on shared infrastructure underneath. That's been addressed, but it's a useful reminder. Any privileged role touching this stack deserves the same scrutiny you'd apply to any other high-trust assignment. Defender extends into this picture too. Threat protection already watches for compromised accounts. Now it covers agent-driven attacks specifically. It looks for prompt injection attempts, unsafe tool invocations, or an agent being manipulated into acting outside its purpose. Investigation and hunting can correlate agent activity with user actions and system changes. An incident involving an agent doesn't sit in a separate silo anymore. And then there's the piece that actually removes an entire category of risk. The credential-less model. No secrets held per agent means no per-agent credential to steal, leak, or forget to rotate. An attacker looking for a stolen API key sitting in a script finds nothing. That key was never there to begin with. Put it together. And this transforms agents from what they've been. They used to be a security blind spot nobody fully monitored. Now they are governed and observable. They are evaluated by the same risk engine, the same conditional access policies, and the same threat protection tooling already protecting every human identity in your tenant. That's not a parallel security program. That's one program. Finally covering the whole population it was always meant to protect. The licensing reality. Now let's talk about what this costs and who needs it. The pricing model tells you exactly how Microsoft expects this to get deployed. Agent 365 standalone runs $15 per user per month. That starts on May 1st, 2026, the same general availability date we covered earlier. If you want it bundled, Microsoft 365 E7 comes in at $99 per user per month. That bundle includes E5, Copilot, Entra Suite, and Agent 365 together. If you buy those four pieces separately, you're paying more than bundling them under E7. But here's the detail that trips people up. This is licensed per user, not per agent. You're not paying a fee for every individual agent instance spawned from a blueprint. You're licensing the humans who govern those agents. The sponsors, the admins, the people actually touching the control plane. An organization running 2,000 agent instances off a handful of blueprints only pays for the platform team's seats. They don't pay for 2,000 separate agent licenses. This matters because it directly shapes how you should be thinking about your structure. It rewards centralization. A small team governing many agents costs far less than the same agent population spread across dozens of unlicensed departmental owners. Before you can even buy this, there are prerequisites, and they vary depending on where your organization sits. Enterprise customers need Microsoft 365 E5 as the qualifying base. Frontline worker populations need Defender plus Purview Suite FLW. SMB customers need Business Premium. You don't get to bolt Agent 365 onto just any tenant. It sits on top of a security and compliance foundation that has to already be in place. There's also a split between what's free and what requires payment. Basic agent discovery doesn't require a license. That's the visibility that lets you see agents exist in your registry. But the governance layer we've spent this entire episode building toward is gated behind the paid tier, the analytics, the enforcement, the deeper policy controls. You can see your agents for free. Governing them costs money. One more thing worth flagging clearly, there's no consumption meter on Agent 365 itself, at least not yet. It's a flat per-user fee. What isn't flat is the AI runtime underneath it. Copilot credits, Azure token consumption, whatever compute your agents are actually burning to do their work, that's built separately from the governance layer entirely. You could hold your Agent 365 licensing costs steady while your runtime bill climbs significantly. Those are two entirely different meters, measuring two entirely different things. Step back and look at what this pricing structure assumes. It assumes most organizations won't try to license every employee individually against every agent they touch. It assumes governance gets concentrated in a small, accountable team, sponsors and administrators, rather than the whole workforce. That's not just a pricing choice. It's Microsoft quietly telling you what operating model they expect to actually work at scale. The registry and discovery. Agents need to find each other. This is where the registry becomes critical. It's a piece that often gets overlooked because it doesn't feel like security work. It feels like plumbing. But you can't govern what you can't see. The registry is what makes agents visible in the first place. Think of it as the central catalog for every agent in your organization. It doesn't matter which platform built it or which team owns it. Every blueprint and every instance shows up here. This isn't just a nice-to-have dashboard. It is the source of truth for what your agent population actually looks like. Each entry carries an agent card. This is metadata describing what the agent does, what it can reach, and how it connects to other systems. That card lets a human or another agent understand an unfamiliar identity without having to dig through configuration lines. You look at the card, you know the purpose, you know the scope, and you know the owner. That last part matters more than it sounds, because agents don't just get discovered by people, they get discovered by each other. An agent built for customer intake might need to hand a task to a billing agent. It queries the registry, finds the right card, and initiates that handoff. Discovery here isn't about granting access. Permissions are still governed through the roles and policies we already covered. The registry answers a narrower question. Does something exist that can help with this? And where do I find it? For organizations with a large agent population, you don't want everything visible by default. That's where collections come in. These are groupings by business function, environment, or approval status. You might keep a finance-approved collection separate from an experimental one. This stops people from tripping over half-finished pilots while looking for production tools. The closest comparison is the employee directory. That's the list that shows a name, a title, and a way to reach someone. The registry does that same job for agents. It's not access control. It's the mechanism that makes a population discoverable. Instead of scattered across silos that nobody can see into, there's also a quarantine capability. If an agent starts behaving badly or fails a risk review, you can pull it from discovery. You don't have to delete it. It stops showing up in searches. But the object and its audit trail stay intact for investigation. That distinction between hiding and destroying matters when you're trying to understand what went wrong. None of this replaces the governance layers we've already built. The sponsors, the scope permissions, the conditional access policies. The registry sits underneath all of it. It's the layer that makes the rest of the system honest. A sponsor can only be accountable for agents they know exist. An access review can only cover agents someone remembered to include. Without a registry, governance quietly degrades. You end up only governing the agents you happen to remember, and that is exactly the failure mode this entire structure was built to eliminate. The attended versus unattended decision. Not all agents operate the same way. This distinction shapes every governance decision downstream, so we need to be precise about the difference. An attended agent acts on behalf of a signed-in human. Someone is actively in the loop. The agent works with delegated permissions tied directly to that person's session. Picture someone drafting a proposal in Word. They ask an agent to pull last quarter's numbers into a table. That agent isn't operating under its own independent authority. It's an extension of the person sitting there. It is bounded by whatever that person is already allowed to touch. An unattended agent is a different animal entirely. No human in the loop, no session to inherit from. It acts under its own identity. It is governed by the roles assigned directly to its blueprint. Think of a nightly process that scans invoices for anomalies. It doesn't wait for someone to log in. It runs on its own authority. It runs on its own schedule. And it has its own accountability chain back to its sponsor. This split matters for a very practical reason. When an agent is attended, your existing policies for that human already apply. If that person needs a compliant device, the agent inherits that requirement. You're not building new policy. You're extending policy you already trust. Unattended agents don't have that luxury. There is no human context to borrow. These need agent-specific policies and risk-based controls. There is no user session to lean on for signals like location. The entire risk evaluation has to stand on the agent's own behavioral baseline instead. The token mechanics reflect this same split. Attended agents typically use an on behalf of flow. They request permission that traces back to the user's consent. Unattended agents authenticate directly. They use the blueprint's credential model. There is no user token involved anywhere in the chain. These are two different authentication paths because there are two fundamentally different trust relationships underneath them. This isn't a minor toggle you set once and forget. It shapes permissions. Delegated access is bounded by the user. App-assigned access needs its own explicit scoping. It shapes your governance posture. Unattended agents demand a more rigorous risk model because there is no human fallback. And it shapes incident response. When an attended agent misbehaves, you're investigating a person and a session. When an unattended agent misbehaves, you're investigating an identity that acted entirely on its own. There is no human decision point to interrogate in the moment. If you get this classification wrong at design time, you'll spend the next year retrofitting policies. But if you get it right, everything else slots into place. The sponsors, the policies, the risk detection, it all works because the foundation is correct. Conditional access for agents. Conditional access extends zero trust to AI, but here's how that actually gets built into policy. Agent conditional access is now a first-class policy target inside Entra ID. It isn't a workaround. It isn't bolted onto an existing rule set. When you build a policy, you select agents as its own assignment category. It sits right alongside users and workload identities. That matters because it means you're no longer forcing agent governance through a structure designed for people. You're targeting the object type directly. Agent risk plugs in as a condition. It draws on the same intra ID protection signals we covered earlier. You can build a policy that says, if this agent's risk level crosses a threshold, block the token request, or require a step-up control before it proceeds. That's the enforcement hook. It turns detection into action, because detection without an enforcement point is just an interesting log entry. This is what makes the signal actually do something. Resource scoping is where this gets genuinely precise. You aren't limited to a blanket allow or deny for an agent's entire existence. You can restrict a specific agent identity to specific APIs, specific applications, and specific data sources, nothing beyond that boundary. Pair this with the scoped permission model from the blueprint architecture. Now you have two independent layers narrowing what an agent can touch, the permission grant itself, and the conditional access policy standing in front of it. Before you flip any of this into full enforcement, use the phased rollout capability. Policies can run in report-only mode first. You see exactly what would have been blocked or challenged without disrupting a production agent mid-task. An agent population can grow fast once departments start requesting their own instances. Testing in report-only mode isn't optional caution. It's the only realistic way to validate a policy before it touches something running unattended at 2 in the morning. But here's the problem. It's easy to misread how this works if you expect it to behave like user access. The enforcement point sits at token acquisition. Conditional access evaluates the moment an agent requests a token. It does not evaluate every single downstream action that agent takes after it has one. So if an agent successfully authenticates and then calls 15 different tools across a task, conditional access made its decision once, at the gate, not 15 separate times along the way. That's a deliberate design choice. It isn't a gap someone forgot to close. The real authorization happens at runtime. The fine-grained decision about whether this specific action should be permitted happens inside the agent platform itself. It uses the scope permissions and roles we've already built into the blueprint and instance layers. Conditional access is the checkpoint at the door. It's lightweight by design, because asking it to reevaluate every single tool call would turn a policy engine into a bottleneck nobody's runtime could tolerate. So what's actually happening is two systems working at two different speeds. Conditional access handles the slower, higher stakes question. Should this identity be allowed to operate right now? The agent platform handles the faster, higher volume question. What exactly is it allowed to do with this specific call? Neither one is trying to do the other's job. And that separation is precisely what keeps the whole model workable at scale. It doesn't collapse under its own overhead. Identity protection for agents. Agents can be compromised. Detection is built in now. And this is where the risk signal actually gets defined. Agent risk isn't one signal, it's a cluster of them. Anomalous behavior, access patterns that don't match history, activity suddenly reaching across tenant boundaries when it never has before. Entra ID protection watches for all of this simultaneously. It builds a picture of what a specific agent identity typically does. Then it flags the moment that pattern breaks. That picture comes from behavioral baselines, and this is worth sitting with for a second. Entra ID doesn't apply a generic rule to every agent equally. It learns what normal actually looks like for each individual identity, because a document summarization agent and a finance reconciliation agent have wildly different normal patterns. Treating them identically would either miss real threats or drown you in false positives. When something crosses that baseline, the response isn't a ticket in a queue. It isn't for someone to review next week. High-risk agents can be denied a token in real time, automatically, the same instant the risk signal fires. That's the enforcement point we described earlier, the token request gate. It's now acting on identity-specific behavioral data instead of a static rule. Investigation is where this pays off for the person who has to figure out what happened. The logs don't just show that something was blocked. They show why. What specific deviation triggered the flag? What the baseline expected versus what actually occurred. That context is the difference between an analyst spending 20 minutes understanding an incident and spending half a day reconstructing it from scratch. But here's the shift. There is a distinction that trips people up if they think about this through a human risk lens. An agent legitimately touching 500 documents in 10 minutes is unremarkable. That's what a retrieval-heavy agent does on a normal Tuesday. A human account doing the same thing in the same window is almost certainly a compromise in progress. Same raw number. Opposite conclusion, because the baseline being measured against is entirely different. This is exactly why agent-specific risk modeling isn't optional. Borrowing the thresholds built for human accounts and pointing them at agent traffic would be a mistake. You would either lock down legitimate automation constantly or miss the actual anomalies buried underneath normal-looking volume. Defender integration extends this further. It connects agent risk signals to the same threat detection already watching for compromised accounts elsewhere. An agent-driven attack doesn't sit in an isolated silo. It isn't separate from everything else Defender is correlating. It's part of the same investigation surface, the same hunting queries, the same attack chain reconstruction your security team already runs. Put together, this closes a gap that used to be uncomfortably wide. Agent compromise used to mean discovery weeks later, usually through an unrelated audit or a data leak surfacing somewhere downstream. Now it means the same response speed you'd expect from a compromised human account. detection, evaluation, blocking, all happening in the moment, all tied to an identity that carries its own behavioral history instead of borrowing rules built for someone else entirely. The 30-day roadmap to an agentic workforce. Here is how you actually build this. Blueprints, sponsors, conditional access. None of that matters if it stays on a whiteboard. You need a plan, a 30-day roadmap, 4 weeks, each with one specific job to do. Week 1 is about the baseline. Before you build anything new, you have to find what already exists. You need to inventory every agent currently running in your tenant. Even the ones nobody is tracking, the ones a team spun up 18 months ago and forgot about. You are hunting for orphans. Agents with no clear owner, no documented purpose, lingering access that nobody remembers granting. Once you have that list, you set the rules. Who can create an agent? What do baseline permissions look like? What does the sponsor requirement actually mean for your team? And then you assign the sponsors. Every single agent on that list gets a human name attached to it. No exceptions. No, we will figure it out later. This is the accountability structure locking into place immediately, not eventually. Week 2 shifts to construction. Build and ground. This is where you start creating actual agent blueprints. But you do it deliberately. Pick 2 or 3 high-value areas like support, finance, or HR, places where an agent can produce measurable value quickly. While you build, you handle data grounding. You connect these new agents to enterprise search and the knowledge bases you actually trust. This ensures every answer they produce ties back to something real. Instead of something invented, it is the no source, no answer principle we talked about. You build it in from day one, instead of trying to fix it after a problem surfaces. Week 3 is about integration. Your blueprints exist. They are grounded in real data. Now, they need to live where your people actually work. You wire them into Teams, into Outlook, into SharePoint, into the systems your team uses every single day. An agent that only works in a separate console is just another tab collecting dust. It adds no value if nobody opens it. At the same time, you stand up the approval workflows, the sponsorship reviews, the access cycles that keep the system honest. This is where governance stops being a setup task and becomes a rhythm. Week 4 is when you harden the system. This is where the security layers actually get switched on. You apply conditional access policies to your new agent population. You enable risk detection so strange behavior gets caught the moment it happens. Then, you test your incident response. Use a specific agent scenario, because responding to a compromised agent is not the same as responding to a human account. You want to know that before you are doing it under pressure. Alongside that, you build the monitoring, dashboards that show activity at a glance, audit logs that people actually review, anomaly detection tuned to how these agents actually behave. 30 days, 4 phases, each one builds on the last. If you skip the inventory, you are building on top of a mess. If you skip the grounding, your agents produce answers nobody can trust. The sequence matters as much as the work itself. The sponsor model and accountability. Governance only works if someone is accountable. We have mentioned the sponsor in every section because it is the thread that holds the architecture together. But let's look at what that role actually demands. Because saying every agent needs a sponsor is easy. It is easy to turn it into a checkbox that nobody takes seriously. The sponsor is the human who owns the agent, its existence, its behavior, not in a symbolic way, but a functional one. This person approved the agent. That approval carries weight. They are the one who certifies its access every few months. They are the one who manages its retirement when the work is done. There is a distinction here you need to get right. The sponsor is not the developer. It is tempting to assume the person who built the blueprint is the owner. They understand the technical details best, right? But technical authorship and business accountability are different things. The sponsor is the business owner, the person who can explain why this agent exists, what problem it solves, and whether that problem still needs solving 6 months from now. A developer can build something without ever being able to answer those questions. Accountability shows up through attestations. Sponsors do not sign off once and disappear. Every quarter, they confirm the agent is still needed. They make sure it isn't picking up permissions it no longer requires. This gives the access review a specific face and a specific cadence. The sponsor is also the first point of contact when things go wrong. If an agent starts pulling data, it shouldn't. The path leads to them, not to a generic IT queue, not to an engineer who happens to be on call. It goes to the person who understands the agent's purpose, the person who can judge quickly if this is a bug or a compromise. And this is where the model closes the loop. What happens when a sponsor leaves the company or moves to a different role? Under the old model, the answer was usually nothing. The identity just kept running, quietly detached from any real ownership. It became an orphan. Under this model, that departure triggers a review. Automatically, no sponsor, no operation. Someone has to claim accountability. Or the agent is retired. That single mechanism is what makes this different. No orphans by design. It doesn't rely on someone remembering to clean up. It is built into the lifecycle itself. When you put this together, you get something new. Not shadow it running in the background, but governed digital workers. Each one has a named human standing behind it, behind its access, behind its behavior, exactly like every other person on your payroll. Purview and data governance for agents. Agents interact with sensitive data. We touched on grounding and DLP earlier, but there is a deeper layer of enforcement sitting underneath all of it. That layer is purview. It starts with your DLP policies. This is the piece that does the most immediate work. The rules already governing how sensitive data moves through your organization now apply directly to agent activity. The same rules for what can be shared externally and what triggers a block versus a warning. Now watch every move an agent makes. If an agent tries to move a labeled document outside an approved boundary, it hits the same wall a person would. Retention rules apply the same way. Sharing restrictions apply the same way. The policy doesn't care if the entity is a human or an agent identity spawned from a blueprint. The rule is the rule. Information protection labels extend that same logic to classification. A file marked as highly confidential carries that label regardless of what is requesting it. Agents respect that classification the same way a properly configured session would. This means the labeling work your organization already invested in doesn't need to be rebuilt or rescoped just because agents entered the picture. It was already doing the job. Now it is doing that job against a larger population of identities. E-discovery and legal hold work on this same principle, but we need to be specific about what changes here. We already established that agent-generated content is discoverable. What Purview adds is the mechanism that actually preserves it. Legal hold applied to a mailbox or a shared document library now extends to capture agent output tied to that same scope. This ensures a hold doesn't quietly miss half the relevant record just because an agent produced it instead of a person. Insider risk detection is where Purview starts doing something new. It isn't just extending an existing control. It watches for patterns that look wrong at the agent level specifically. Bulk downloads that don't match a task's expected footprint. Activity suddenly crossing into a different tenant boundary. Access patterns that deviate from what that particular agent normally does. This isn't the same signal Entra ID protection evaluates for authentication risk. It is a data behavior signal. It sits one layer up. It watches what happens after an agent already has a token and is actively moving through content. I'd describe the effect as something closer to a magnifying glass than a gate. Purview isn't deciding whether an agent gets access in the first place. It is watching what that access actually produces in real time. It flags the moment behavior around sensitive data, stops looking like the agent's established pattern. And these policies aren't static. Enforcement can tighten dynamically based on how sensitive the data is and how risky the agent has been flagged elsewhere in the stack. An agent operating cleanly against low-sensitivity content might see minimal friction, but that same agent reaching towards something classified as highly restricted encounters a stricter version of the same policy automatically. The same thing happens if the agent carries an elevated risk score from a recent anomaly. What this closes ultimately is the gap that made agents dangerous in the first place. The ability to move data quietly, without triggering any of the compliance machinery already protecting your tenant. That gap doesn't exist anymore. Data governance built for people now covers the agents acting alongside them, evaluated by the same rules, held to the same standard, with no separate, weaker track running underneath. Defender and threat protection for agents. Agents are targets, not theoretical ones, actual ones. Defender treats them exactly like any other identity worth protecting. It doesn't bolt on a separate, weaker security track just because they are automated. It starts with AI security posture management. This is the piece that catches problems before they become incidents. It is constantly scanning your agent population for misconfigurations, permissions that drifted wider than intended, blueprints that granted more scope than the use case actually required. This is posture assessment, not incident response. It is answering a quieter question. Before anything goes wrong, where are we already exposed? Runtime protection is where things get active. Defender watches agent behavior as it happens. It can block malicious actions in real time instead of just flagging them for review after the damage is done. An agent attempting something outside its intended function gets stopped at the moment of the attempt. It isn't discovered 3 days later in a log review that nobody scheduled. Attack chain detection extends that further. A single flagged action rarely tells the whole story on its own. Defender connects an agent compromise to the broader sequence surrounding it, what led up to it, what it touched afterward, and whether it is one isolated event or a link in something larger moving through your environment. That connective view is what separates a contained incident from one that spreads quietly while everyone is looking at the wrong piece of it. Two specific attack patterns deserve naming directly. They are unique to how agents actually get manipulated. Jailbreak and prompt injection attempts try to talk an agent into acting outside its intended behavior. It is essentially social engineering aimed at a non-human target instead of a person. Defender is built to recognize these attempts specifically. It doesn't just look for generic anomalies, it looks for the particular shape a manipulation attempt takes when the target is a language-driven system. Unsafe invocations get handled at the enforcement layer directly. If an agent tries calling a dangerous API or reaching toward a resource outside its permitted boundary, that call gets blocked before it executes. This sits alongside the scoped permissions we built into the blueprint architecture, but it is a distinct check. It evaluates the action itself in the moment, not just whether the underlying permission technically exists somewhere in the grant. Investigation and hunting is where all of this becomes usable by an actual human analyst. Agent activity correlates directly with user actions and broader system changes. An investigation never treats an agent incident as its own isolated puzzle. It isn't disconnected from everything else happening in the tenant, it is one continuous picture. Agents and humans are woven into the same timeline. What this ultimately delivers is parity, plain and simple. The same threat detection depth your organization already built for human identities now covers agents too, not a scaled-down version. Not a best effort add-on shipped later because someone remembered agents existed. The same posture management, the same runtime blocking, the same attack chain reconstruction. All of it applied to a population of identities that, until recently, sat almost entirely outside anyone's threat model. The multi-tenant complexity. If you operate across tenants, the model gets more sophisticated. This is where the architecture has to handle a problem the single tenant view doesn't prepare you for. What happens when the organization building an agent isn't the same organization running it? Start with the distinction between a publishing tenant and a consuming tenant. An independent software vendor building an agent for broad distribution creates that agent's blueprint in its own tenant, the publishing side. But the customers actually deploying that agent are consuming tenants. There could be dozens or hundreds of separate organizations involved here. Each one is running its own instance of something they didn't build and something they don't directly control at the template level. That relationship works through blueprint service principles. Each consuming tenant that adopts a published blueprint gets its own service principle, and that principle links back to the original blueprint sitting in the publisher's environment. This isn't a copy of the blueprint itself, it's a tenant-specific manifestation. It holds the credentials and configuration relevant to that one organization's deployment, while the underlying template stays owned and maintained by the publisher. Nothing about that instantiation happens automatically or silently. Consent and approval sit in front of it deliberately. A consuming organization has to explicitly agree to use a given blueprint before any agent instances can spawn from it inside their tenant. That approval step is the same trust boundary you'd expect from any third-party application requesting access to your directory, but it's applied here to an agent template instead of a traditional app registration. Once that consent exists, the scaling potential is significant. A single blueprint maintained in one place by the publisher can power agent instances running across 100 or more separate organizations simultaneously. Each of those instances still carries its own agent identity. Each one still gets its own sponsor requirement inside the consuming tenant, and each one still logs its own activity independently. The publisher isn't managing every individual instance directly, they're managing the template. While consuming tenants manage the accountability layer for what runs inside their own boundary, that split creates a specific kind of audit alignment. Each consuming tenant sees its own agent activity in full, including its own logs, its own risk signals, and its own sponsor attribution. This is exactly the visibility we covered when we walked through observability earlier. The publisher, meanwhile, maintains the blueprint itself. They are responsible for what the template defines and how it behaves, without necessarily having visibility into every downstream tenant's specific usage patterns. Two different parties, two different scopes of accountability, both operating against the same underlying object. What this ultimately enables is ecosystem-level scaling without collapsing tenant isolation. An ISV can build once and distribute broadly. It's the same efficiency that makes traditional multi-tenant applications viable at scale. But every organization running that agent keeps its own governance boundary fully intact. They keep their own sponsors, their own conditional access policies, and their own compliance posture. None of it is inherited or diluted just because the underlying template came from somewhere else. The blueprint travels, the accountability doesn't. The agent user extension, some agents need to be more human-like. And this is where the architecture we've spent so long on runs into its own boundary. Everything we've covered up to now, blueprints, agent identities, service principal subtypes, is credential-less and service principal-based by design. That design works cleanly for an agent calling APIs, reaching into data sources, or executing tasks under its own authority. But it doesn't work for everything. Because some systems, Exchange mailboxes, Teams conversations, the organizational chart itself, are built around the assumption that whatever's interacting with them is a user object. They aren't looking for a service principal wearing an agent label. That's the gap the agent user fills, and it's explicitly optional. You don't create one by default. You create one when an agent genuinely needs to show up in Teams, or receive mail in Exchange, or appear as an entry in the org chart alongside actual employees. Most agents running background tasks, reconciling data, or monitoring systems never need this extension. It exists specifically for the subset that has to operate in spaces built around human presence. The relationship here is a parent-child structure. It's not a replacement. An agent user doesn't stand alone as its own independent identity floating separately from everything we've built. It's tied directly to its parent agent identity. It inherits that lineage, that sponsor accountability, and that audit trail we covered under observability. The agent user is an extension of something that already exists. It's not a second disconnected identity requiring its own separate governance model bolted on afterward. What that extension actually unlocks is fairly specific. Mailbox capability means an agent user can hold an Exchange mailbox and receive email directly, the same way a person would get looped into a thread. Team's presence means that agent can participate in conversations and channels. It's visible the way a colleague is visible, not hidden behind an API call nobody in the room can see happening. And org chart visibility means the agent actually appears in the organizational hierarchy. It's a digital entry sitting alongside the human entries around it, discoverable in exactly the way employees are discoverable. I want to be precise about where this sits in the maturity timeline. It's easy to assume everything in this episode is equally available today. It isn't. This piece is still in frontier preview, not general availability. It's not something you're deploying broadly into production this quarter, but it's worth understanding now, because it's the clearest signal of where the roadmap is heading, toward agents that don't just execute tasks quietly in the background, but sit inside the same collaborative spaces your people already work in. They become addressable the same way a colleague is addressable. That's a meaningfully different kind of integration than anything we've discussed so far. Everything earlier in this episode governs what an agent can access and who's accountable for it. The agent user governs how an agent shows up, how it's found, how someone reaches it without needing to know which platform built it or which blueprint spawned it. It's not a governance layer, it's a presence layer. And it sits on top of a governance model that already has to be solid before you'd ever want an agent visible enough to email directly. Observability and logging. You can't govern what you can't see. Everything we've covered so far. Sponsors, conditional access, risk detection. It all depends on one thing sitting underneath it. A record of what actually happened. Observability isn't a feature you bolt on after the big decisions are made. It's the foundation the entire structure rests on. It starts with agent sign-in logs. This is dedicated telemetry. It was built specifically to capture how agents authenticate and how they get their tokens. It's separate from the general sign-in stream your directory creates for human users. When an agent requests a token through its blueprint, that event is recorded with the specificity the identity deserves. It isn't folded into a generic service account log, where it's indistinguishable from 100 other things. Activity logs go one level deeper than authentication. Every action an agent takes is recorded with full context, not just that something happened, but what was touched, when it happened, and what authority was used. That's the difference between knowing an agent existed and knowing what it actually did while it was running. And this is where we connect back to the architecture. Logs don't just show that an agent acted, they show the blueprint lineage. They show which blueprint spawned that specific instance, tracing the identity back to its template, its permission inheritance, and its original configuration. If something looks wrong with one instance, you aren't investigating in isolation. You can pull every other instance spawned from that same blueprint to see if the problem is contained to one agent, or if it's baked into the template itself. Sponsor attribution closes the loop from the other side. Every logged action ties back to the agent, to the blueprint, and to the human accountable for that agent's existence. This is the sponsor model made operational inside the logging layer. It isn't a separate lookup someone has to perform manually when an incident starts. The accountability we talked about earlier isn't just a policy commitment. It shows up directly in the record. All of this feeds into Azure Monitor. This telemetry doesn't live in a silo built only for agents. It feeds into the same infrastructure your security and operations teams already use for everything else. That matters. It means agent activity is correlated alongside every other signal your teams are already watching. You don't need a separate tool that nobody outside the AI team ever opens. There's also a specific capability you need to know, the isAgent filter. Inside your existing logs, you can isolate agent activity from user activity with one click. You don't have to manually pass through mixed telemetry trying to guess which entries belong to which category. When you're investigating at speed, that filter is the difference between minutes and hours. This visibility does two jobs at once. It satisfies governance compliance, giving you the evidence trail auditors expect when they ask how an agent's actions map back to a human. And it satisfies incident response, giving your security team the same investigative depth for an agent that they'd expect for a human account. Neither of those outcomes is possible without this logging layer. Every mechanism we've described, sponsors, blueprints, conditional access, it all depends on a record that proves it actually worked. The ecosystem and platform integration. Agent ID doesn't exist in isolation. The identity model, the governance layers, the observability, it all sits underneath a broader ecosystem of platforms where agents actually get built. You need to understand this ecosystem because your agents won't come from just one source. Most organizations will start with Copilot Studio. It's the low-code platform. It's built for teams that need to stand up an agent without a dedicated engineering team, a business analyst building a support agent, or an HR lead building an onboarding assistant. That work happens here. But here's the thing, whatever is built in Copilot Studio still gets a proper agent ID. It still gets a blueprint. It still follows the exact same governance model. Low code doesn't mean low governance. As your AI Foundry sits at the other end of the spectrum, this is the pro code platform. It's for agents that need real orchestration, custom logic, and complex reasoning that a low-code builder can't express. This is where your engineers build the sophisticated agents that handle complicated business processes. Different audience, different tooling, same underlying identity architecture. Power Platform threads through both of these. It connects agents into Power Automate flows and Power Apps, wiring them into the processes people run every day. An agent built in Foundry can trigger a Power Automate flow. One built in Copilot Studio can surface inside a Power App. The platforms aren't walled off, they interlock. Then there is Microsoft Foundry. This is the managed platform where agents run at scale with the observability we just walked through. It handles the tracing, the monitoring, and the evaluation that keeps a production agent population healthy. It's less a place where you build, and more a place where things operate once they move past the prototype stage. We also have MCP, the Model Context Protocol. This is the standard connecting agents to tools and data sources regardless of which platform built them. Instead of every agent needing a custom integration to reach a system, MCP gives you a common language. An agent from Foundry and an agent from Copilot Studio can both reach the same tool through the same protocol. The platforms don't need to understand each other's internals. What ties all of this together is the registry. The registry doesn't care where an agent came from. Every agent appears in that central catalog regardless of the platform, the discoverability, the classification, the visibility. It all applies whether the agent was built by a business analyst or an engineering team. That interoperability is what keeps this model from breaking. The moment your organization uses more than one tool to build agents, which you will, the model holds, you aren't maintaining separate governance for separate platforms. You're governing agents. Full stop. One identity model, one registry, one set of sponsor and access rules. The rules don't care which logo appeared on the builder's screen. The competitive advantage, early agent governance, is a structural advantage. It sounds like a compliance burden if you only look at it through security, but in reality, it's a business strategy. The organizations treating it that way will out-execute the ones treating it like paperwork. It starts with first-mover governance. Teams building sponsor models and blueprint standards right now aren't just checking a box. They're establishing the patterns everyone else will eventually have to copy. Being the organization with a working template when new regulations land, or when the board asks about AI accountability, is a different position than scrambling to build one under pressure. That leads directly into compliance readiness. Regulators will eventually demand agent auditability, and given the trajectory we've traced, that demand is coming. Organizations with sponsor attribution and full activity logging already in place simply produce the evidence. There is no emergency remediation project, and no 6-month scramble to reconstruct what an agent did 2 years ago. The answer already exists in the logs. Data protection follows the same logic. If you've already built the Purview integration and the DLP enforcement we walked through earlier, you've prevented the leak before it became a headline. That isn't a defensive posture you prove after the fact. It's already done. Incident response compounds this advantage even further. An organization that has tested its response process against a compromised agent, the way we described in the 30-day roadmap, responds to that threat as fast as they would a compromised human account. The organization that never ran that test is discovering the truth in real time. They're learning during an actual incident that agent compromise doesn't behave like the playbooks they already have. There's also an organizational learning dimension here. Companies governing their agent population properly are the ones who understand, concretely, how agents actually change the shape of work inside their walls. They know what tasks genuinely got faster. They know where an agent created friction instead of removing it. That understanding doesn't come from good intentions. It comes from having enough visibility and structure in place to observe it honestly. And finally, cost control. It sounds mundane next to security, but it matters just as much. Agent sprawl without a registry or lifecycle policies doesn't just create a headache. It creates runaway consumption and licensing waste. It creates forgotten instances, quietly consuming resources that nobody is tracking. Preventing that sprawl from the start is cheaper than untangling it later. Put together, none of this reads as a security story anymore. It's a competitive one. The gap between organizations who built this early and those who didn't will be visible within a few years, not decades. The roadmap and what's coming. Agent ID is evolving. And it's worth being clear-eyed about what's ahead versus what's already locked in, because treating a moving target as if it's finished is its own kind of mistake. Agent conditional access service plans are set for a July or August 2026 rollout. This brings full licensing alignment to something that is currently in a provisional state. What you're building today under preview conditions will need revisiting once that lands. Not because the architecture changes, but because the licensing scaffolding finally catches up to the capability. Identity protection for agents follows a similar arc. The risk detection and behavioral baselines we walked through earlier are heading toward general availability. This means more automated response and less manual intervention. The detection logic matures. The action it triggers becomes less dependent on a human sitting in the loop. The agent user extension is also moving from frontier preview toward production. This includes mailboxes, Teams presence, and org chart visibility. That is a meaningful shift. It changes which agents are viable candidates for that kind of integration. Right now, you're testing it cautiously. Once it hits GA, it becomes a real deployment decision for any agent that needs to sit in collaborative spaces. There is also a potential shift worth naming, even though it isn't confirmed, per agent licensing. Everything we've described up to now licenses the humans governing agents, not the agents themselves. That could change for fully autonomous agents specifically, agents operating without a human directly in the loop on a regular basis. Nothing here is locked in yet, but it's a signal worth watching because it would change how organizations budget for scale. Runtime authorization integration is where the architecture keeps deepening. We've been clear that conditional access evaluates the token request. Not every downstream action an agent takes afterward. That gap is closing. We are seeing deeper hooks into policy engines and finer controls that reach further into what happens after the token has been issued. Cross-cloud federation extends the model outward. It moves beyond the Microsoft ecosystem entirely. The concepts we've spent this episode on, blueprints, sponsors, and credential-less identity, aren't necessarily staying confined to one vendor's infrastructure. That's a bigger shift than it sounds. It suggests Agent ID isn't just a Microsoft feature. It's becoming a pattern other platforms will need to reckon with. All of this points toward a single baseline by 2027. Agent governance stops being a differentiator. It becomes table stakes. It won't be something advanced organizations do to stand out. It will be something every organization running AI at scale is simply expected to have. It's the same way multi-factor authentication went from a selling point to an assumed default. None of this changes what we've spent this episode building toward. It just sharpens the timeline. What's optional today becomes mandatory tomorrow. The organizations already operating with sponsors and full observability won't need to scramble when that mandatory line arrives. They'll already be standing on the other side of it. The mistakes organizations will make. Most organizations will get this wrong. The failures won't be exotic or surprising. They are predictable. We see them repeated by teams that have all the right information, but still trip over the same handful of errors. The first mistake is treating Agent ID like a feature you just enable. It isn't a toggle in a menu, it is a governance architecture you have to adopt. What usually happens is IT teams flip the switch and register a few agents. They think the job is done, but they never build the sponsor model or the blueprint standards. They skip the review cycles that actually make this identity type useful, without governance wrapped around it. An Agent ID is just a fancier service principle. The second mistake is failing to assign sponsors. This recreates the exact problem we started with. If an agent doesn't have a named human accountable for it, it's an orphan. It doesn't matter how sophisticated the underlying architecture is. The label on the account changes, but the risk of abandonment stays exactly the same. Then there is overprivileging agents. This usually happens because of convenience. Scoping permissions precisely takes a lot of work. Teams under a deadline grant broad access instead. They tell themselves they will narrow those permissions later, but later rarely comes. You end up with agents holding power far beyond what they actually need to function. This is the exact pattern that made service principles dangerous in the first place. Ignoring the registry is a quieter mistake, but it undermines everything else you do. When an agent is built outside the discovery system, it doesn't show up during an audit, it doesn't participate in the sponsor model, it doesn't get caught by conditional access policies, it is invisible by omission, in a live environment. That is the same thing as being invisible by design. Skipping conditional access is its own category of error. Some organizations set up their roles carefully and stop there. They assume role-based controls are enough. They aren't. Without context-based enforcement, an agent can have the right permissions but act at the wrong time. It might trigger from the wrong location or under conditions that should have been blocked. A subtler trap is assuming agent risk works like user risk. We talked about this distinction earlier. An agent touching 500 documents in 10 minutes isn't necessarily a threat. It might be doing exactly what you programmed it to do. Teams that use their user risk intuition here end up drowning in false positives. Or worse, they tune the detection so loosely that real attacks slip through. The most expensive mistake is delaying implementation. Organizations wait until an auditor asks an uncomfortable question instead of building the answer now. You can fix the other mistakes incrementally, but waiting for external pressure means building under a deadline you didn't choose. You'll be dealing with visibility gaps that have been growing for months or years. The cost here isn't abstract, it's compliance violations. It's data breaches that nobody can trace back to a person. It's a slow loss of trust in AI systems that were supposed to be assets. You don't need a sophisticated attacker to reach these outcomes. You just need these ordinary shortcuts, left alone long enough to compound. The structural shift in summary. So what is actually changing? You are moving from shadow IT to governed digital workers. Agents now hold first-class identities instead of borrowed permissions. You are moving from credential sprawl to centralized blueprints. Security is architected in, not bolted on at the end. You are moving from orphaned accounts to sponsored responsibility. Every agent answers to a named human. You are moving from static roles to dynamic governance. Lifecycle policies and reviews now run continuously. You are moving from blind spots to observable systems. Every action is traceable. You are moving from compliance risk to compliance readiness. This is built by architecture, not by policy documents. This isn't an incremental change. It's a structural one. The window to govern agents is closing. Organizations that wait will inherit chaos. Agent 365 and Agent ID aren't optional anymore. Start now. Inventory your agents. Assign sponsors. Build blueprints. If this changed how you think about agent governance, follow me, Mirko Peters, on LinkedIn. And if you want more of this, subscribe to the podcast.